Hi Physics, so this is part 2 of that video. This is homework 5, problem 3. This is the skiing downhill problem. So remember, we've done all this work. We've done all the hard work by now. We've just got to finish it from here. We did step 1. We drew it very carefully. We drew our triangle very carefully. That was going to be real important because then we had to draw this other triangle, this guy right here. And that's tricky to do, especially if you don't have the first one correct. So we did all that. We got a free body diagram, which I ended up drawing twice. So here's our free body diagram again. This one is correct, but we had the problem of this ugly vector here, f sub g. So we had to make that vector pretty according to our new coordinates, which is what we did over here in step 0. After I did that, I went and I did a new step 2, this time only with the pretty vectors. So now I have 2 pretty vectors in the y direction, in the new y direction, and I have 2 pretty vectors in the x direction. So I can just keep going from here. So again, this is not going to be any different than the other ones. It's any other two-dimensional force problem. Do the y side first, and then do the x side. So I guess I'll keep going with black because it's a new screen. Do step 3 and do the y side first. So step 3, sigma f sub y with a hat is equal to ma sub y with a hat. Now let's think of a sub y again. Let's go back to our sketch. And remember that our new y direction is this one. Y now means out of the hill. So if we're thinking, what is a sub y? How quickly is Denise accelerating out of the hill? She's not. She's not flying off into the air, and she's not flying into the hill either. So what that means, just like in the other problems we've done, a sub y is going to be 0. So our whole right side is going to end up being 0. That'll be nice. Sigma f sub y, just like before, I get those terms by looking back at my free body diagram. So I'm going to grab my 2 y direction forces. And remember, in our new y direction, those forces are just going to be this guy and this guy. I'm ignoring the other ones for now. So I have to put hats in those things. Well, f sub n with a hat plus f sub gy with a hat. On to step 4 on the y side. Just like before, this is math. And the first part of math is take the hats off, put in the signs. So if I look at my free body diagram, f sub n, this is in the new up direction, so that's going to get a plus. F sub gy is in the new down direction, so that's going to get a minus. So when I take off the hats, I'm going to have f sub n minus f sub gy. And all this is equal to 0. Remember, I'm trying to solve for f sub n. So I add f sub gy to both sides. I'm going to end up with f sub n is equal to f sub gy. Now, if we go back to our step 0, I've actually already figured out what f sub gy is. That's this guy right here. So that's 481.7 newtons. 481.7 newtons. Put a box around it. Do a step, does this make sense? I solve for the right thing. Normal force, it's in units of newtons. So this is good. I've got that one right. The next thing we do is step 3 on the x side. So step 3, x side. Sorry, that isn't x. So we have sigma f sub x with a hat is equal to ma sub x with a hat. So let's look back at our sketch. Denise, she's skiing. She may be accelerating downhill, so we can't just say that a sub x is 0 because it might not be. So that means I'm keeping the right side. A sub x is not 0. So for now, I just copy this again, put a hat on a sub x. Sigma f sub x. Go back to our good free body diagram. Grab all of our x direction forces. So that's f sub k, f sub gx. Put hats on them and plus them together. So f sub k with a hat plus f sub gx with a hat. On to the math. Step 4 on the x side. First part of doing the math is take the hats off, put in the signs. Let's look at our free body diagram again. F sub k is going in our new negative x direction. It's going left up the hill, so that's going to get a minus. F sub gx is going in our new positive x direction. It's going to the right down the hill, or to the right along the hill. So when I take off the hats, that means I'm going to have negative f sub k plus f sub gx. And all of this is equal to ma sub x. And again, I actually have to guess which way we're accelerating. Your life will be easier if you just assume, if you guess that it's accelerating to the right, meaning the new right, to the right along the hill. So we've got that. I'm trying to solve for a sub x. So to get a sub x by itself, I'm going to divide both sides by m. When I do that, the m's cancel over here. So now I just have a sub x on the right side. I'm going to switch left and right. Let me just recopy this real quick. That's going to give me a sub x is equal to minus f sub k plus f sub gx, all of this over m. So f sub gx, I figured that out back in step 0. M I knew, that's the mass, that's 60 kilograms. F sub k, again, look at the footer at the bottom of the page and go to the numbers for that. Or, I'm sorry, go to the formula for that. F sub k is still equal to minus, F sub k is equal to mu sub k, the minus is there separately, times the normal force, which is the number we figured out in part A, plus f sub gx. All of this divided by m. So now we have to go to the numbers. So that's going to give us minus mu sub k is 0.150. F sub n is that 481.7 number that we worked so hard to get before. 481.7 newtons. Plus f sub gx. So let's look back at step 0. That's this number here, 337.3. Newtons, and all of this divided by the mass. And the mass is 60 kilograms. So when you're doing this in the calculator, if you're not doing it correctly, there's a good chance you'll get it wrong through the order of operations. The way I would actually do it myself is minus 0.150 times 481.7 plus 337.3, and then I would hit enter. So I got the whole sum of the whole, the entire top part, and then divide that by 60. That's the way I would actually do it. If you don't want to do it that way, another way you can do it is put parentheses around these guys. Just make sure you're getting the whole the whole numerator on the top, and then dividing by the 60 kilograms. If you do it wrong, you end up only dividing the second term. You end up with the wrong number. So if I do all this in the calculator, if I get it right, I end up with 4.42, and this is an acceleration, so meters per second squared. Put a box around it, and then do step I was looking for acceleration in the x direction. I expected to have meters per second squared as its units. And I ended up with acceleration in the x direction, and I have the correct units. So I'm giving it a check. Step works. So hopefully this helps. Let me just quick review the whole thing from the beginning, because this is a different kind of problem. Because it's on a hill, that makes it weird. So we started off with step always start off with that. Figure out what are you looking for, what units you expect it to have. Then I did step 1. Draw your step 1 very carefully. Make sure you're getting your triangle correct. If your angle is less than 45 degrees, make sure you're drawing it that way. Because if you don't draw that first triangle correctly, it's going to be really hard to get the second triangle correct. And especially, it's going to be really hard to figure out, is this my angle here? Is this the same theta that I started with over here? Or should this be theta? The first thing was right. You've got to draw the triangle correctly. So I did all that stuff. I got to a step 2. Again, the key is I'm using a new coordinate system. Straight up is not y anymore. Y is now up and out of the hill. And x is not straight to the right anymore. X now means along the hill. So that gave me a new, I just copied down my step 2 again. And then I had 2 pretty vectors. These guys are okay, but I had 1 ugly vector. So I had to do a step 0 to that guy. Again, the importance of getting the triangle correct. That's really the only way to know that that is where your angle belongs. Then I did all of my trig. And I did a small, medium, large test at the end to make sure my numbers were small, medium, and large. Definitely good to do that check when you're doing this because these problems are tricky. After I did that, I turned my ugly vector into 2 pretty vectors. I went and redid step 2. So this time I've only got my pretty vectors. Everything is either in the new y direction, the new negative y direction, the new negative x direction, or the new positive x direction. So I did all that. And then from there, it's just a 2-dimensional force problem. Do Newton's second law, do the y side first to get the normal force, because you need the normal force to figure out the friction. So, yeah, step 3 on the y side, all that stuff, figured out the normal force. Then I went to the x side. Again, Newton's second law, this time in the x's. Did all that stuff, did the math, took my hats off very carefully, put in the signs correctly, did all of this math, substituted in for f sub k correctly, did all this real careful, included my parentheses so I got my order of operations right, and then finally got a reasonable number, 4.42 meters per second squared. If you're skiing downhill, that seems like a reasonable rate at which to accelerate. So this is the tricky problem again. Hopefully this video helps.